Okay, so this is just going to be a quick little video. Some of you may know how to do these problems, but some of you may not. I just don't know what all of your background was because we haven't done it in here. So we're going to talk about how to find the distance between 2 points as well as how to find the midpoint between 2 points. So anyway, there's a couple of different ways that you can actually execute that kind of mathematics. So let's just go ahead and get started with that. So the first idea is if we're going to find the distance and midpoint between given coordinates, there's several styles. And normally when you think about it, if you have two coordinates x1, y1, and x2, y2, and any time in mathematics that you have these subscripts, those are very different than exponents. It's like names. This one is like the first x, and that's the second x. You could think about this being as Phyllis and George or something like that, just two different names. And so they actually indicate that you have some given piece of data, like that's going to be a number 5, or that's going to be a number -6. It's just some given value. Now, obviously, that's something that just by looking at it, you wouldn't know. But there's a nice thing that you can do is if you draw a line straight across and straight up and down, we could always turn this thing into some kind of a vertical and horizontal line. That would make the distance between them right here just the hypotenuse of a right triangle. So as it turns out, when you move along a horizontal line, the y value never changes. So this value right here is also y1. It's the same height as this guy. But when you move along a vertical line, the x value never changes. So this one right has the same value as the one above it. Now that's actually sort of helpful because since this is a horizontal line, this distance right here is just x2 minus x1. It's just the difference of the two x's. Now we usually put absolute values on that when we write this out because distances cannot be negative. That's just like an ironclad rule in math, cannot be negative. Similarly, y2 take away y1 is going to be the distance here. Since the x values don't matter, they're vertical, we just take the difference of these two. Again, a little absolute value. So that's going to tell you something. The distance between them is going to be x2 minus x1 squared and y2 minus y1 squared. And so all I'm doing is I'm doing a squared plus b squared equals c squared. But again, I don't really want c squared. I want c itself, or in this case, d. So d would be the square root. Now, see these absolute values that we put in there? We usually drop those off in this case because the absolute value makes it positive, but so does a square. So the typical way that this particular formula is written is this way right here. That's a good formula. Not a bad formula. And you might recall that we used a similar formula back in the day. Remember earlier in the course, in one of the earlier delta math things, we said the slope was rise over run, and the rise was this y2 minus y1 guy, and the x2 minus x1. And we actually call this thing over here a slope triangle usually because it's easy to see. But in my verbiage, I've got you guys to call this delta y and delta x. So there's an alternative way to look at this because if y2 minus y1 is delta y and this one is delta x, or in other words, the change in y and change in x, delta just means change. This is just the change in x squared and the change in y squared. So some people like it in the formal version right here using the fancy values. Some people like this one right here where we just kind of look at those differences. And so let's take a look at a couple of quick examples. So if we were to come in here and use the formulaic version, remember 1 just means the first one. So that's the first x, first y, second x, second y. So the formula says, let's take the difference of the second x, that was x2, take away x1. We have to be really careful with our negatives there. Plus the difference of y2 and y1. That's 1 minus 7. Now, obviously, there's a lot of places where I guess decimals and negatives can get in the way, but here's what I see. -4 squared is 16, because keep in mind, You would get negative here, but we're going to square that anyway. Over here, we're going to have -6, and we're going to square that, and we have 36 for a grand total of root 52. Now, we have discussed in here that 52 is 2 times 26, but 26 is 2 times 13. So we could simplify this all the way down to 2 roots of 13. Now, if you happen to have graph paper, some people prefer to just come in here and sketch it. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And so if we come across and we come up this way, you can see that right here we have 1, 2, 3, 4. You'll notice that that was that 4 squared that was sitting right here. And from here was 1 all the way up to here, which was 6. You're going to notice that 4 squared plus 6 squared equals 13, 2 roots of 13. Now, one of the things that I discussed with you guys earlier in the year is similar triangles can be very, very powerful. So if you made these smaller, because these things are in a ratio where they both have a 2 in common, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. So that makes this root 13. And so again, what you could see is since the black numbers are twice as big as the similar red numbers, you would make the black number twice as big. There we go. Now, like I said, I personally like the other version. I like that using that the distance is delta x squared and delta y squared. So when I look at this, I say, well, shoot, what was delta x? Well, x started at 3, and it dropped all the way to -1. So I just say it was -4 squared. Then I come over here and I say, well, what happened to y? It started at 7, it dropped all the way to 1, that dropped 6. And you're going to notice the same thing. That's a 16, that's a 36. We're going to get our information. So on this last problem, I'm going to go ahead and do it the way that I personally like to do that. So if, again, my distance would be right here, the 1 and the 5, they have grown by the number 4. The 8 all the way down to 13 has dropped a total of 11. Quick value here is 14. 4 squared is 16. That's 121. For 11 squared, keep in mind -11 squared is the same as +11 squared. And I got root 137, which happens to be prime, and so I don't have to simplify it. Now, you notice that I have this thing sitting over here because there's a portion of the video that I actually have not addressed yet, and that has to do with the fact that I mentioned midpoint. So we're going to look at midpoint as well. Now, to do the midpoint of anything, what we do instead is we're trying to find what value would be right here in the middle, some new value. But what's interesting is all you have to do for it, this is actually one of the easiest formulas in math. Midpoint is the middle point, and all you have to do is add the 2 x's and cut them in half. Add the 2 y's and cut them in half. And I think you know that anytime you add 2 numbers, divide by 2, you're going to get an average. So it's really, really easy to do. We're literally just going to add and divide by 2. So in this particular problem right here, if we added 3 and -1, 3 plus -1 divided by 2, comma, 7 plus 1 divided by 2, that's going to be 1, that's 2 over 2, and 7 plus 1 is 8 over 2, which is 4. So I'm over here at 1, comma, 4. And I know I probably should not have written quite all of this information in here, but I'm going to go ahead and take a look at this right here, because there's something really nice that happens is if I connect the dots right here to this new coordinate 1, comma, 4, you should notice that this new triangle right here is going to be similar to the big triangle. And this was kind of the red numbers that I had written a minute ago. That goes over 2, that goes up 3, this is root 13. But by similarity, this little triangle is in the 2-to-1 ratio, or half of the large triangle, and you could see that information. Now over here, This one is actually a little bit harder. That's why I did it. 1/8. I'm going to go ahead and I wish I had made my axis a little bit lower, but because it's going to be too high. Shoot. Well, that's all right. So I'm not going to use the graph paper, but anyway, if we add the x values, 1 plus 5 is 6 divided by 2, and 8 plus -3 is 5 divided by 2. And obviously, there's a lot of people that are going to be bothered by that, but there's nothing that states that a midpoint has to be at a nice whole number value. Sometimes, you know, what's the average of 1 and 3? It's 2, but sometimes you get 1 and 2 and you get 1.5. If you have 5 cookies and there's 2 friends, then you don't each get a whole cookie. You know, you each get 2 and then you split the last one in half. That's just kind of how mathematics works. So that's like phase 1 and 2. There's one additional little piece that I'm not going to spend too much time on, but imagine I told you that I have x1, y1. Some coordinate is 5, 1. And then I've got some midpoint over here. And I told you that the midpoint was 2, -3. Now, there are a couple of different ways to do that. One of those ways that I see people do occasionally is they use that formulaic approach, that somehow, if you add the two x values and divide by 2, I'm supposed to get the x value. If I add the two y values and, if I add the two y values and divide by 2, I'm supposed to get the y value. Now, you can kind of think about this a little bit, that 5 plus, well, I can cross multiply, might as well do that. 5 plus x2 is 4. That's going to make x2 the number -1. I've got it. Nice. And then over here, if I cross multiply, 3 times 2 is 6, and that's going to make y2 the number 5. So I can kind of tell that my midpoint is the number -1, 5. That's the coordinate. But I actually kind of do it a little bit of a different thing, because anytime something is in the middle, if we go back to the picture that I had up here, to go from here to here, I went over 2 up 3, but then to go from here to here, I did another over 2 and up 3. So when I personally look at these, I could look at the equation, or I could just say, hey, what do you know? To go from here to the midpoint, it dropped 3. So let's drop 3 more. From here to here, it dropped 4. Looks like I made a mistake. Dropped 4, it should drop 4 more. So this one should be -7. Boy, I'm having a rough morning this morning. Something's wrong. Oh, and I see what I did wrong. Right in here, I messed up that I made this a 3 instead of a -3. So that should be -6 and therefore -7. That was kind of silly of me, but you know, that's just kind of how math is. And that's one of the reasons why I personally, this was not planted, like to look at things in a couple of different ways to make sure that I don't do silly things. Anyway, that's your little post-test delta math on distance and midpoint. I'll see you back in class. Bye-bye.